Hello everyone, my name is teacher Thant, and today I'm going to cover the first chapter 10 of Unit 3, Property of Waves of Pearson Edexcel Physics. So some of the topics that we are going to cover today is, first thing is we are going to learn about transverse waves and longitudinal waves. Afterwards, we need to learn about the common terms that we use to describe waves, such as amplitude, wavelength, frequency, or time period, and learn two formulas which relate between amplitude, wavelength, and frequency. And we're going to take a brief look at the experiment, which shows us very clear demonstration of wavelength and frequency relationship through a ripple tank. And then we are going to learn what are the common properties or the similar properties of all types of waves, properties such as diffraction, reflection, refraction, and finally the Doppler effect. So first things first, there are two types of waves called mechanical waves and electromagnetic waves. Now, mechanical waves, they require a medium to pass through, such as air or water. Now, you might think that air is actually vacuum and not a medium, but no. Air actually has a lot of particles that is being used as medium for mechanical waves to pass through. Now, if you do not require a medium, we call them electromagnetic waves. They can travel through solid walls or even vacuum. So the two types of mechanical waves are transverse wave and longitudinal wave. We will learn the details about that in a second. Now, transverse waves are sort of like water ripples, and the medium for the water ripples to occur is the water. And one example of longitudinal wave are sound waves. They will travel through air for you to be able to listen to different types of sound. And as for electromagnetic waves, since they don't require a medium to pass through, some examples that you can relate to are infrared rays and ultraviolet rays of the electromagnetic spectrum, radio waves and X-rays that we use in medical industry, and microwaves. So the difference between transverse wave and longitudinal wave is that a transverse wave, it is a wave which vibrates or oscillates at right angles to the direction in which the energy or the wave is moving. So you can look at the illustration here as well to understand it better. But essentially, this blue line that I'm drawing is the direction of the wave, which is the same for both transverse wave and longitudinal wave. But the only difference is that in transverse wave, your vibration, okay, or your oscillation is going to be at right angles to the direction of your energy or your wave. And as for longitudinal wave, your vibration is going to be parallel, or we can also say that it is along the direction in which the energy or the wave is moving. Now, some of the examples of transverse wave are light waves and water waves, and some examples of longitudinal wave, as I've mentioned before, are sound waves. Now, it is quite important for you to remember some of the examples, because in exams what they can do is they can either give you the waves and then ask you, is it a transverse or a longitudinal waves, or they can simply ask you, give us one example of transverse wave you know and why it is a transverse wave. Now let's try to use some terms to describe waves. So the diagram here, it is a simple diagram which you will see again and again in properties of waves and waves related chapters. This is a very simple diagram to describe a wave. So the first vocabulary or term that we are going to learn is called amplitude. It is the maximum movement of particles from their resting or equilibrium position. So this line here, right here, is our equilibrium or resting position. If we don't say anything, if we don't produce a sound or any wave, it's going to be stationary. But once we begin to speak or produce a wave, it is going to create waves, as in blue line that you can see here. And the maximum distance or the maximum movement that these particles are going to move is called the amplitude. So you should notice that this is not your maximum, so that's why it's not an amplitude. This is not as well, but this is your maximum amplitude, and in the same way, the lowest one is also your maximum amplitude. So if you look at the diagram on the right side, do not confuse this in your exam. Only either the top part or the bottom part is your amplitude. You can either take this as your amplitude or this as your amplitude, but not both of them. Okay, there will be twice the amount of your amplitude. So another vocabulary that you need to know is called the wavelength. So the wavelength essentially means the length of a wave. Now, if you pay attention, you won't make this mistake in the future. All right. So the length of a wave is the distance from one point, a particular point on a wave, and the same point on the next wave. Okay. So let's see an example. Right now, this is a wave. This is a wavelength, one complete wavelength. Now this is also a wavelength. It starts at the same position, ends at the same position. This is also a wavelength, and this is also your wavelength. Okay, we can also say this from crest to crest. Crest means the very top part or where your amplitude is. So if we talk about mountain crest, it means the top of the mountain. Now the time period or the T is the time taken for one wavelength to complete or travel. For example, this is the time period. This is your time period as well. This is your time period as well, and this is your time period. Okay, so in exam, if they ask you to come up with the wavelength or something, please understand that they are not asking you the distance for the entire diagram, not here to here. It is only asking a wavelength, so it should be just about this. Okay, so that's all that you need to mention. And the time period or the T is the time taken for the wave to travel one wavelength. The very top parts are called crests or amplitudes. Now, there are two formulas. Okay, the third one is just a varied formula for the second one. So the most important equation that you need to learn is the wave speed is equals to frequency times wavelength. So it's called V is equals to F lambda. I'm sure that you are familiar with two of these before. So velocity is simply the same as before, which is meters per second. Your frequency, this is the new unit that you need to learn. It's called hertz. And wavelength, since it is the length of a wave, it will be meters only. Alright, so we are strictly following the SI unit here. And time period is given in seconds. So in exam, if they give you hours or minutes, make sure that you convert them into seconds first before you proceed on with your calculations. Very important. This is a mistake that many students do. Similarly, for wavelengths, make sure that your units are very consistent, alright? Because if they give you wavelength in centimeters and you don't want to convert it, know that your wave speed will also be centimeters per second. Okay, but it cannot be meters per second on one end and centimeter on the other, and vice versa. Alright, let's take a look at the ripple tank experiment. So we can study the behavior of water waves by using a thing called a ripple tank. When we turn on the water motor, okay, the water motor will look like this. this is on the diagrams on the left side are real life applications. Okay, so you will see that there is a motor here which represents this area. When the motor is turned on, the wooden bar will start to vibrate and it will create a series of ripples or wave fronts on the surface of water. And how are we going to measure or see the waves? We are going to put a very bright lamp on top of your device right here. Okay, so it's going to cast shadow created by the waves, and it will form wave patterns on the paper below or on the ground below, and we are simply going to measure it by using a ruler here, and you'll be able to measure your wavelength. So in here, let's think about a concept. Okay, so initially, if your frequency, okay, the rate at which your wooden bar is touching the water is low, which means that it's going to hit it 1, 2, 3, 4, or if it starts to hit faster, if we turn on the power more, it's going to hit it more frequently, meaning your frequency will be higher. It will hit like this: 1, 2, 3, 4, 5, 6, 7. Okay, so what you should notice here, that when the frequency was low, your wavelength was very much longer, but when your frequency becomes become higher, your wavelength becomes very short. Okay, I cannot even draw it here. Now if we try to look at this in terms of equation, it essentially looks like this: V is equals to F lambda. Now if we take F as if we take the velocity as a constant, it is simply F varies 1 over lambda. Okay, meaning that if your frequency is high, if the rate at which if the number of times which the wooden block is touching the water is high, the frequency is high, your wavelength will be very short. And when your frequency is very low, just like this case, when your frequency was very low, your wavelengths are much longer. Okay, so this is just a simple experiment, and the concept that I want you guys to notice here is that frequency is inversely proportional to wavelength. Now let's take a look at one of the properties, the common properties about waves, which is called diffraction. So imagine, right, when a series of waves, it doesn't matter what type of wave it is, as long as a wave hit a barrier and then it has a gap in the middle, it is still going to carry on and then spread throughout the gap. So the only difference we should look for here is how wide, large or narrow or smaller the gap is. Now if we have a very wide gap, okay, which will be very similar to the length of your wave, you should notice that your waves are going to propagate as curves, as waves. But if your gap is very narrow and much smaller than your entire wavelength, your waves are going to go like this. I'm sorry about the first one. Let me go back and rephrase this. If your wavelength is very much similar to the gap, your waves will propagate like this. All right, so a simple this diagram can be simplified as this one. Okay, if your gap is very much similar to your wavelength or very large, you will have a curve like this. Notice that in exams you also have to draw this way, and it gets larger because it is a wave. If your gap is very small, you will have a simple wave like this, which is very similar to your Wi-Fi signal. And also, just a general knowledge is that when you have a very narrow gap such as this one, which you can even see in your own houses, we are going to create very sharp shadows here. But if your gap is super wide or very large, such as the open door here, we will not have any no sharp shadows. Okay, we will not have any sharp shadows at all. So there are some pictures taken by using a large gap and a narrow gap, and you can also even see here that for your large gaps, your waves will propagate in this manner, and for very small gaps, your waves will propagate like your Wi-Fi signal. Okay, so again, if your gap is larger than the wavelength, it will cause little spreading, and if your gap is smaller than your wavelength, it will cause huge spreading. Okay, all right. So all types of waves have the same fundamental properties, which are reflection, refraction, diffraction, and interference. We are going to essentially learn about three things here, which are reflection, refraction, and diffraction. So all waves that we know can be reflected, and if they hit a straight or a flat barrier, okay, such as this one, the angle at which they hit the angle at which they hit the barrier will be the same as the angle at which they are going to leave the barrier. So for our barriers, we can draw a straight line right in the middle, and we're going to call this a normal, and we will measure the angle between your approaching wavefront, which we would call the incident ray, and the angle between your reflected wave or reflected ray and your normal is called the angle of reflection, and those two will always be the same, and that is why the law of reflection states that your angle of incidence is equals to your angle of reflection. Alright, refraction. Now, if we take a look at refraction, right, let's try to put a pencil into the water, a cup of water, and you will see that the pencil is curved. Now, it is not because the pencil curved in the water, it is because the light waves in water, okay, they are more dense. The water is a more denser medium than air itself. That's why light waves are going to travel much more slowly than in air, because in dense medium where there are a lot more particles, your speed of light will become slower, and this will cause a change in direction, and that change of direction is what we call refraction. So this is a very simple definition that you can study for your exam. Okay, refraction is the change in direction of a wave when it was passing from one medium to another, caused by the change in speed. All right, and this is also a very good comparison between reflection and refraction. You will notice here that your incident ray and your reflected ray is identical, because the angle at which you hit a surface and the angle at which it will be reflected is always the same, because they are in the same medium. But for the refracted ray, it will be less. Okay, it will be less because of the second medium, which is a lot denser than your first medium, and it causes a change in speed of your wave or light, causing it to bend. Okay, so the term that you will see more in the future is the angle of incidence, the angle of reflection, and the angle of refraction. Make sure that you know the difference between reflection and refraction, because students always tend to confuse these two. Now comes the Doppler effect. So when this is a police car and it is producing sirens, and the person A and person B can both hear it. When the car is not moving, both persons can hear it, at the same volume because they have the same frequency and same wavelength. Okay, so it would be like 1 2 3 4 5. It will be 1 2 3 4 5. But let's imagine the car to be moving. Okay, so the wavelength or the wavefronts, they are not they're no longer evenly spaced. Now ahead of the car, the wavefronts, they will be compressed because the car is moving in this direction, meaning that the distance between the person B and the car is getting smaller, is getting compressed. Okay, so your wavelength becomes very much shorter. That's why, as I mentioned before, frequency varies 1 by lambda. So as your wavelength is becoming shorter, your frequency is getting higher, so this person hears a very loud noise. However, the distance between person A and the car is becoming longer and longer, meaning that the wavelengths are becoming longer in between these two. So it should be like this, very long wavelength, and then this will be a very short wavelength. So you will notice that since the person behind person A, the wavelength is getting longer for him, the frequency is going to be low, meaning that he is going to hear a decreased pitch with longer wavelength and lower frequency, meaning that he's going to hear it at a lesser volume. And this entire phenomenon is called the Doppler effect, and the definition that we can use to sum it up is the change in frequency which happens when a source of wave is moving. Okay, this is a source which is releasing or emitting the wave, sound waves, or whatever type of waves. Okay, but the frequency is going to change because of the distance and the wavelength. That effect is called the Doppler effect, and it is a property of all the waves. Now, the important concepts to understand after watching this video is the difference between transverse waves and longitudinal waves. You should be able to draw the diagrams and give examples. The diagram can be as simple as for transverse wave. It should look like this. First, you mention about the direction of the wave or the energy, and you talk about, and then you will draw the vibration of your wave. Okay, since it is perpendicular, we will draw it this way. You can try to draw uneven arrows because you want to represent a wave. And as for longitudinal waves, what you can draw is you have vibrations along the line which is parallel to the direction of the energy of your wave. And there are 4 terms that you should familiarize with yourself before moving on to the next chapter or video, which is frequency, wavelength, amplitude, and crest. And the formula V is equals to F lambda, and the relationship between F and wavelength. And finally, you should learn the basic ideas of what the diffraction is, reflection is, refraction is, and Doppler effect. You might be asked to give very simple explanation on these concepts. Alright, so we have summarized everything that we intended to learn today. So that is all for Unit 3, Chapter 10, Properties of Waves, and I'll see you again next time. Bye bye.